Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription really makes a difference and helps this channel grow. If you enjoy our content and don't want to miss our upcoming videos, subscribe to the channel and turn on the notification bell to receive all updates. Is teleportation really just science fiction? Imagine closing your eyes in New York and opening them a moment later in Tokyo. No planes, no ships, not even moving. An instant jump through space. Science fiction, right? Maybe. But what if I told you that science has already begun to write the first lines of this story? For decades, the idea of instantly transferring objects or people from one point in space to another remained confined to the fascinating realms of science fiction. We imagined it in the novels of Asimov, in the pages of Philip K. Dick, in legendary series like Star Trek, among the decks of the Enterprise and the boldest visions of the future. It was a technological dream, a fascinating fantasy, but, in the eyes of science, impossible. At least until recently. Today, thanks to extraordinary advances in quantum physics, what once seemed impossible is beginning to take on tangible form. No, we're not yet talking about materializing a human being on the other side of the world with a beam of light. But something surprisingly close is already happening, in the heart of the world's most advanced laboratories. Quantum teleportation, a real phenomenon, experimentally demonstrated and continually evolving. In 2024, an international team of researchers took a step that may be remembered in history books: the quantum teleportation of a state of light along a 30 km fiber optic network, operating not in a sterile, controlled laboratory, but within the active data traffic of an urban internet network. This experiment is not just a technical demonstration. It is proof that the quantum internet, a totally new infrastructure for human communication, is no longer a futuristic idea, but a project already under construction. But what exactly is quantum teleportation? And how is it different from the classic teleportation we see in movies? To understand it, we need to dive into the heart of quantum mechanics, perhaps the most mysterious, counterintuitive, and fascinating theory ever devised. At the center of this theory is a phenomenon as extraordinary as it is real: quantum entanglement. When two particles become entangled, their states become intrinsically linked, to the point that any change to one will immediately affect the other, even if they are billions of kilometers apart. Einstein himself, with a touch of ironic skepticism, called it spooky action at a distance. Today, however, it is an experimental reality demonstrated in hundreds of tests. Quantum teleportation exploits exactly this principle. Unlike science fiction, it doesn't transport matter, but the quantum information contained in a particle. In other words, it doesn't move the physical object, but its quantum state. A qubit, a particle that can exist in a superposition of states, can be transferred from point A to point B without ever physically crossing the space between them. This is made possible by a pair of entangled particles in classical communication. The incredibly sophisticated process works like this: an entangled pair of particles is generated. One is kept at the starting point, the other at the destination. The qubit to be teleported is made to interact with the first entangled particle, and a joint quantum measurement is performed. This measurement destroys the original, but transmits, through a normal classical communication channel, the information needed to recreate the same quantum state in the destination particle. The result? The quantum state has been transferred instantaneously from A to B. Matter hasn't moved, but the information has, as if a ghost of the qubit had leapt through space. This effect is deeply counterintuitive, but perfectly aligned with the laws of physics. No information breaks the unbreachable limit of the speed of light, because a classical transmission is still required to complete the process. However, from a quantum point of view, the transfer appears instantaneous. For years, this phenomenon was observed only in hyper-controlled environments and over minimal distances, of just a few centimeters or meters. But the 2024 experiment, the result of a collaboration between CTEC and the QTech labs in the Netherlands, showed that it is possible to teleport quantum states over long distances in real-world conditions, laying the foundation for a true global quantum network. This quantum internet will have extraordinary capabilities. It will allow quantum computers to connect with each other, distribute complex calculations in real time, and above all guarantee absolute cybersecurity. Since any attempt to intercept the information alters the quantum state, it will be impossible to spy on the data. Encryption will no longer rely on algorithms, but on the inviolable laws of physics themselves. The possible applications are enormous: quantum cryptography, completely unbreakable communications, distributed computing. Multiple quantum computers can work together in a network. New sensory and medical technologies, thanks to the extreme sensitivity of quantum states. Expansion of theoretical physics. We might reconsider the very nature of reality. Naturally, there are still enormous obstacles. Quantum teleportation is extremely delicate, subject to the slightest disturbance. Quantum coherence, the ability to maintain a quantum state unchanged, is fragile and can vanish in milliseconds. It requires near-perfect isolation, atomic synchronization, and advanced infrastructures. But, as always in the history of science, what is difficult today may become trivial tomorrow. And as laboratories around the world continue to perfect this technology, the questions multiply. Will we ever be able to teleport macroscopic objects? Maybe a glass, then a chair, then a living being? And if consciousness itself were linked to quantum processes, as some still speculative theories suggest? Could we one day transfer the mind? Could teleportation become the bridge between science, philosophy, and even spirituality? And if, in the end, the entire universe were a gigantic quantum system, interconnected in ways we are only beginning to glimpse? Today, teleportation is real. Fragile, imperfect, limited. But real. And this is not science fiction. It is the first step of a silent revolution, invisible to the eye, but potentially capable of changing everything.